Hello, today I'm going to show how to analyze s2p files in Keysight ADS. S2p files show two port S parameter measurements that can be captured either from a vector network analyzer like this here, PNAX, or provided by a component manufacturer. In this case, I will be using the s2p files provided by Mini-Circuits here for this monolithic PHA1H plus amplifier. You can see right here they have the S parameters listed. You can usually always find them here where you find the data sheet. This is a common technique that I myself will implement regularly in the industry to help analyze a component's expected performance and actual performance once placed in a system. So first I'll start with showing just one simple example where we load a file in. Then I'll show a comparison of multiple s2p files to show the real power of this technique. Typically the first thing I like to do is take our s2p files, which I have here already downloaded, and I like to add them into the data folder for the workspace that we're in. You can usually just go here and go to the data folder within this directory, or you can just right click and go to explore in the file system and it'll open it up here. You can just copy and paste them here. It just makes things a little easier. So we'll go ahead and we will start a new schematic. We'll just call this single example. And the beauty of using this, the data from this device is that you can see right here the manufacturer provided different bias voltages as well as different temperatures. So that lets us really get to see what the expected behavior for this component will be before we even buy it, if we decide we want to use it. So we open this up here, and what we'll do, we can just search directly for s2p. It has this little block. Put that in there. We'll need terminations. Add our terminations here. Then we'll need to connect these with a wire. We'll also need to add that to ground for that. So we connect these with the wire. It's very simple, very straightforward, but it ends up being very powerful. We'll also need our S simulation, our S parameter simulation. So we'll add that in there. So now this is basically it. We have it all set up. We just need to upload the file itself and the parameters. So we'll go in here. You can click on this. We see here we will want to upload the file here. So we just go to browse and it opens directly into this data folder. This is why I'll put them in here. It's easy to find, especially when you have to start adding multiple of them. So we'll just take this first one right here at 4.75 volts at negative 45 degrees Celsius. Upload this s2p file right in there. We can name the block if we want. So as we see there, we click apply and it shows us the file that's in there. We can click OK. Now we need to set up our parameters for the simulation. So typically we'll just go to our data sheet for this, which I have here. We'll just take a look and we see right here we have our broadband feature. We go from about 50 megahertz up to 6 gigahertz. So that's what we will use here. So we'll start with 50 megs, go up to 6 gigahertz, and I will just run 201 data points. Now, if we're using a exported file from a VNA, we should know exactly what these parameters are. We want to set this up exactly how the VNA measured. That way we can see exactly what it's putting out. But for now, we'll just have that. There's also the potential to need some other parameters. There's times where I'll need to take a look at the group delay. So we can come over here under parameters. You actually need to check this group delay box here for that to happen. So we can actually use that data. So we come back, we can just click apply. Now everything's good to go here. So we should be able to just click simulate. Now we have our data display. And typically, we usually want to look at our S11 or S21, our reflection and our insertion loss. But we put the display in here, and we can see we have multiple options. We can look at the group delay directly here. We come down here, we have our S parameter measurements. So if we want to take a look at our S11, we just double click that. And there we are. We have that. We can see exactly what we're looking at. We see we have a lot less reflection here in the lower region, and we start to get more as the frequency increases. You can also go ahead and take a look at our S21. And then, as we would expect based on our S11 parameters, our S21, we're seeing we actually are getting more and more loss the higher we are in frequency. And that's to be expected with almost any device. And we can do simple things like label. You can insert like a text box. So we could do that. We could say S11. Let's put the right one. Oh, I can't type right now. S11 reflection. You can label it like that. We can also label it by just going directly into here, going to plot options. We can adjust our plots here. We can label things. This is pretty straightforward. But we can look at multiple different things in here. But this is the basic, straightforward way of doing it. If we want, we can come back in. We can reload a different file. If we just want to look one at a time, now we can look at the plus 25, apply that, and then rerun our simulation, and then it'll come up with the updated. Now, if we want to look at multiple of these at once, it's pretty straightforward. We literally can just take this, copy it, and paste, and paste. And now you see we have 3 of them. We can go into each one individually, and we can change this. Let's just change it to a different random one. We can see what it's labeled here. And change this one as well. And now when we run this simulation, we will be able to differentiate between the S parameters based on these terminations here. So 1 and 2, right? This one will be S1, S11, S12, S21, S22, and so on and so forth. This one will be S33, right? S43, and this one S55, S65. So we will pull up, I already created one that has all 6 on it. So we can see here, this has all the 6 different files loaded, all their different port terminations. And now when we run this simulation, we can actually plot them all compared to each other. And right here, I already have this set up, so it's easy to look at. Pretty straightforward. We have our reflection, our insertion loss, or our gain in this situation, right? Because this is an amplifier. So our S21 is actually going to show us a gain here. But we typically call that insertion loss. We can take a look at our phase. And like I said, sometimes we'll take a look at our group delay, which happens to be the derivative of the phase. It's just the rate of change of our phase. So typically we want a linear phase when we're talking RF. So usually when we're looking at our group delay, we want to see that flat because that means that we're staying at a consistent slope in our phase. And both the phase and the group delay can both also be utilized in signal integrity analysis to help determine if there's impedance mismatches at certain frequencies. And we can also, as you see here, plot our input and our output visuar. Right now, I just have these basically labeled just relative to the actual termination ports. But you can see that we get differences based on that. And using this, we can easily compare multiple different s2p parameters for different systems, the same system with different variables, right? Depending on what you have, this can be a very, very, very powerful tool. Especially if you're either looking at VNA data, right? If you have multiple sets of VNA data that you need to analyze and compare, you can load everything into here instead of trying to sit there on the VNA and pull everything up and try and use a bunch of different screens. This is very powerful for that. You can also take, like I said, you can take what you get from your VNA and plot it compared to what a manufacturer might be providing you, saying is the expected results. So you can see what your system's doing compared to what the expectation is. And you can use that to also help further analyze any sort of mismatches or issues going on within your circuit and your system. So yeah, that's basically it. Very simple, very straightforward, but very, very powerful. Something that I use regularly. It saves a lot of time, saves a lot of headache, especially when VNAs themselves are very pricey. It's not often you're going to find multiple VNAs, so sometimes you're going to have to share them. So a lot of times you're just going to go measure using the VNA and then export that data so that you can further analyze it later and allow somebody else to use that VNA. So yeah, thank you very much for your time today. I appreciate it. If you have any questions, please let me know in the comments. Please like and have a good day.